Hello everyone, and welcome to part 3 of the Item Toolkit Fault Tree Analysis module for performing safety studies. In part 1, we created a new project and a new FTA system where we constructed a small system with an undesired top event called explosion with a logic of an and gate, and we further developed this fault tree by breaking down to the component or function level and finally provided these events at the lowest level with failure models. We looked at the results summary for our FTA and in particular the cut sets for our FTA system, or the combination of events happening or components failing that could together satisfy the top event, and the unavailability or the probability of an explosion over the system lifetime or study time of 8,760 hours. In part 2, we looked at how we can link smaller FTA systems within our project to a master tree, produce tabular reports, as well as exporting the FTA diagrams to printer, PDF writer, as well as directly to a Microsoft Word document. Here in part 3, we will look at how we would manage our failure model libraries, as well as the import and export features, which could save us time for multiple global changes outside of Item Toolkit. Let's first take a look at the example project we built in part 1 called Explosion. Let's open this project and look at the gates and events to see what parameters are missing and whether we can update these parameters in a much faster way to complete our FTA. As we can see, the gates and events have no part numbers or reference IDs, etc. The events all have been assigned different failure models, but as we can see, these failure models do not have a description. Let's say that we need to populate these parameters, and rather than doing them manually, we can do this a much faster way outside of the software by exporting the data, updating them, and re-importing them back in. Let's run the analysis for this FTA system and then export the tables that we need to update. Once the analysis is complete, we will select the top node of the FTA system and select the option from the File menu, Export. The program will create a temporary database in Microsoft Access format as a bridge, and the tables that we select to export will be exported to this database before replicating the same to other formats such as TXT, CSV, or Microsoft Excel. Let's now select the tables that we need to make changes to, which are the Events table, Gates table, and the Failure Models table. We then click on Next, and let's export all of the parameters in all of these 3 tables by clicking the triple arrow button. And finally, we decide which format to export to, and by default this is set to Microsoft Excel, but this can be changed to suit your requirements using this drop-down list. Once we click Finish, the Excel file will be created in the same folder as our project, and we see an advisory message appear asking us whether we would like to save this export process with the selected tables and parameters in order to save time for future exports. Let's save this export as a template and call it FTA Partial Export. Let's now open Microsoft Excel and open this Excel file. As we can see, the 3 selected tables have been exported with all of the parameters. Let's now update the part numbers and reference IDs for our gates and events, as well as the data and description for our failure models. Let's put it Event 001 for the event part number and drag this down. Let's do the same for the reference IDs with Event Ref 001 and drag this down also. Let's now do the same for the gates with part numbers of Gate 001 and reference IDs of Gate Ref 001 and drag this down. Let's now take a look at the failure models table and update the failure rates and the description for these. Let's SE the failure rate to be 0.1 and drag this down to be 0.2, 0.3, etc., and the description for the models to FMDesk001 and also drag this down to complete our data update. Let's now go back to Item Toolkit and our fault tree system Explosion. To import the update Excel file, we would once again select the top node of our FTA system, and this time from the File menu option, we would select Import. We then locate and select our updated Excel file and click on Next. Now we see the tables within the Excel file, and we can use AutoMatch and Match All to complete the mapping of these parameters. Once the import is complete, An advisory message appears asking us whether we would like to save this import process with the selected tables and parameters in order to save time for future imports. Let's save this import as a template and call it FTA partial import. Let's now check our gates and events to see the imported data. As we can see, the gates and events now have part numbers and reference IDs. Checking the failure models for our events, we see that these failure models now have different failure rates and their descriptions have been updated as expected. We can check on this data in a different way. We can look at all of our gate, events, and failure models via the Edit menu option. Let's see a list of our gates where they are filtered by the options for all gates, global gates, and non-global gates. The same for our events list where we can choose to see the different types of events within our FTA system. Looking at our failure models, we see that the program keeps a list of which events are using which models, and here we have various options to assign or reassign failure models to our events. Let's now look at managing our failure models. Looking at the bottom of this failure model library window, we see options for adding new models as well as save as, append, and export. Let's look at the save option and why these were introduced. The idea of managing your failure models is to be able to use the same models for future fault tree projects in order to save time re-entering the same data for new events in new project. Let's click on the Save option and we can see the failure model can be saved in the same folder as our project with an extension of ITF, which stands for Item Toolkit Failure Models. Let's name this FTA Failure Models and click on Save. Now let's open a new project and look at how we would introduce these failure models into this new project. Let's go to the Failure Models table via the Edit menu Failure Models, and as we can see, there are no failure models. Let's now use the Append button to add the saved failure models into this new project. Once we click on Append, the program is expecting a file with an extension of ITF, and once we select our FTA failure models and click on OK, we see that our saved failure models are now in this new project, and we can now start adding a new FTA system and add events to our top gate, and simply select these models from the drop-down list for our events and see the model parameters. Let's now go back to our project explosion and take a look at the Export button in our failure model library. Let's select the top node of our FTA system and go to Failure Model Library table via the Edit menu. Let's now click on the Export button, and as we can see, the table is going to be exported to an Excel file called fmodels.xls. Let's click on OK, and we see the process is finished. Let's now open another new project and import this failure model in. File, New Project followed by File, Import. Let's select this Excel file and use Auto Match and Match All to complete the process. Once this is complete, we can save the import process as a template for future imports, and we can call this fmodels import. Now we can add a new FTA system and take a look at our failure model library via the Diagram View Edit menu options, Failure Model Library. As we can see, we now have these models imported, and we can choose to add events to this new top gate, and then select the failure models from library. I hope this part 3 of the Item Toolkit tutorial on the Fault Tree module has been helpful, and look forward to seeing you in part 4, where we will look at customizing our FTA symbols, fill colors, text font types and sizes, as well as managing our diagram by using Auto Arrange, Auto Fit to Page, and Auto Paginate.